Hello and welcome back to Mount Wilson, where the Astronomers Without Borders are bringing you a live feed of the Venus transit, which is happening right now above our heads. I bring you to our wonderful behind-the-scenes control room, and we have inside Hollywood Airstream graciously donated us this space. And right now we got something very cool happening. We are actually getting in touch with the North Pole, well, near the North Pole, actually in Svalbard. Svalbard is a Norwegian, I'm sorry.
It's okay, we just kind of lost his feed right there real quick.
We've lost the feed. The wonders of
live TV. Let's go to that shot.
Okay.
Let's go.
So
Let's go to Norway.
Okay, so we're back in Norway. Now you can see here in your screen we're actually streaming live to Norway, Svalbard, and in the screen right now is Colin Wilson from the Venus Express Science team, and he's got quite a gathering at the moment. It's quite late, so we apologise for keeping you up very late tonight, Colin. But what's going on there? I mean, for you, I mean, to see Venus transiting the sun, of course this is a very personal and professional delight for you, because you've got a spacecraft orbiting Venus. What does this mean to you personally? I mean, what kind of feelings do you have right now?
So as you say, thanks for the long question. As you say, we've got a spacecraft at Venus now. When I say we, this is the European Space Agency, so certainly all of us in Europe feel a stake in it. And since it's the only spacecraft at Venus currently, well, you can all share in what it discovers and things like this. So Venus Express has been orbiting Venus since 2006 now. It was launched in 2005, and it's going to continue for a few years yet. And that means that it was not in orbit during the last transit. So this is the first of any transits which has occurred while while there's actually a spacecraft at Venus. So we don't just need to rely on the transits to tell us about Venus. We can actually look at it from up close with the satellite, which is great. So the other part of your question is, why are we here? As you might, not an existential kind of question, but why are we up here? You might see in the background that, unlike you guys in Mount Wilson, with all your shades, t-shirts and shorts, we're actually sitting on a pile of snow here. Snow and rubble, and there is ice on behind us here. Here's the snow we're sitting on, in case you didn't believe us. There's some feet modeling the snow here. So why have we come here? It's because this is the only place in Europe. Most of Europe is asleep right now, because it's 2:45 in the morning in most of Europe, mainland Europe. Which means, of course, that they can't see the sun because the sun is behind the Earth. It's nighttime. But if you go far enough north in Europe, you actually you get above the Arctic Circle, and the sun doesn't set. So that's why it's still.
What time is it there in Svalbard right now?
What time?
What time is it there?
It's 2:45 in the morning, and the transit started for us at 4 minutes past midnight, and it's going to continue till almost 7 o'clock. So we might be looking a bit worn around the edges by the time it's finished.
Oh, wonderful. Well, it's about 80 degrees here, so we're feeling for you.
Yeah, thanks.
We're getting a good tan for you.
If you need a bit of refreshment, we'll throw a snowball at the camera. So
you can do that.
Don't worry.
So, I mean, with the Venus transit, I mean, because as you mentioned, you've got your the European Space Agency have got a spacecraft in orbit. How can the observations of the transit from Earth complement the mission? Because of course you're seeing a lot. You get in situ measurements of the planet. How can the observations that are being done now? How can the science be done here? How can it complement the science that you're doing with the mission?
Well, there are two things to say. There are two things to say. I'm getting all kinds of suggestions here from off camera. But there are two ways to answer the question. One is how can Earth-based observations complement the observations we're getting from Venus Express, and that's a whole rich chapter right there. The other thing is to talk specifically about exoplanets and exoplanetary transits. Now, I'm not sure. Now that we're a few hours into your program, you've probably already talked at length about exoplanetary transits. Well, I'm going to say here on screen that transits are a really bad way to characterize a planet. It's a really difficult way to characterize a planet. You can just about detect water and carbon dioxide, oxygen, methane, things which might make a planet habitable, but it's a really difficult measurement to do. And if we had any other choice on how to characterize exoplanets, we wouldn't do it that way because it's really difficult. So we don't know when we characterize these exoplanets if we're getting the answers right, if they actually are nice places to live, if there is water, things like that. So Venus is also a planet. It's passing in front of its star. It's a very rare event, and we can use all the same techniques of transit spectroscopy to try to find out, to ask ourselves, can we detect water? Can we detect oxygen? Can we detect clouds? Can we detect signs that it's a nice place to live? Come up with that analysis, then we just look at we look at what the answers are because we know the answers. From having a spacecraft, we can see whether we got the analysis right. So that gives us more confidence in our transit analysis, so that when we think we found an Earth-like planet in some other solar system, we have more confidence whether we got it right.
Wow. So basically, you're going to use this as an opportunity. Well, you could use this opportunity, but basically, the sun is acting as an analog as a Kepler observation. So this is basically what Kepler would see. Am I right?
Yes. When you say this, it depends which observation you're looking at. Because, I mean, for many of us, looking at the transit is just a question of putting on our glasses going like that. So Kepler is going to have to make a slightly more sophisticated measurement than that. But there are specific observations with observations like the Hubble Space Telescope. I'm not sure if you've talked about that one already. And some other.
Hubble is going to look at the moon, isn't it? It's going to actually look at the reflection of the sun and the transit of Venus from the moon.
And that's a great analog for exoplanetary transits because they use Hubble to look at exoplanetary transits as well. So you're using the same camera to look at the same kind of phenomenon.
Cool.
So yes, it's great. I've got some other people here if you want to talk to some other people as well.
We'd love to speak to more, yeah. It looks like it's getting colder there.
Oh, no. Well, you know, we're past midnight. It must be all warmer from here. So I'm going to pass you over, to act as host here, I'm going to pass you over to to Thomas Wiedemann. Now, unlike the rest of us who have all looked at the transit to feel a place of a sense of history observing this very rare event, Thomas is actually looking at it for science. And not only is he looking at it to do science himself, but he's organized a whole expedition of 9 observers to some 8 or 9 countries around the world. But anyway, Thomas can tell you more. Please.
Hello.
Hi there.
It's pretty cold here, I think.
It's a wonderful 80 degrees over here, so we'll absorb some sun for you.
Well, I just heard that, and I don't want to hear it again. So
Thomas, so tell me about this expedition you're mounting.
Yeah, we designed 9 chronographs. The idea is to... Sorry, I don't think it's the right position. Actually, my fingers are frozen. Yep. Okay. Can you see the great landscape behind? So
yes. Yeah, in our landscape, we've got the inside of Hollywood Airstream. So this is mission control from the top of Mount Wilson. So it's a great system.
Actually, we have one of our chronographs on the west coast. It's not exactly the west coast. It's in Arizona, in Flagstaff.
Oh, wonderful.
Lowell Observatory has one of them, and the result was successful. Actually, we have good reports. So the idea is to use a phenomenon which was described in the 18th century, which was painted on aquarellos or watercolors in the 19th century. It's probably how Lomonosov discovered the atmosphere of Venus in 1761 from Siberia, and this phenomenon is a sort of a halo, of a ring of light around the atmosphere of Venus at the moment Venus comes into the face of the sun, and when it goes outside of the sun. There is a sort of a refracted sunlight. So it's not the usual scattered light which forms the apparent crescent of any planet approaching the sun. It's a direct sort of a lensing effect, a refraction of sunlight through the atmosphere. Mm. And on images in 2004, we realized that there was plenty of science to be made out of this phenomenon, especially that it's probing a region of the atmosphere above the clouds on Venus, which is extremely variable and poorly constrained. There is an indirect measurement of the temperature field. And, the winds are also highly variable there. And that's probably a way of putting together a puzzle of various techniques and measurements in the atmosphere.
And you mentioned there's an enhancement of brightening. Is that what causes that? Because I think it happens around the poles, but why is that?
Well, it's not an enhancement. It's rather a direct lensing of the sunlight through the atmosphere of Venus. So it's about the same brightness as the photosphere of the sun. So this is extremely bright. This is why it could be seen by ground-based observers in the 18th century at the eyepiece. But it's not visible by projection. So it's, as you say, it's somehow it's asymmetrical. It's brighter in the polar region of Venus. It's not exactly brighter, but it lasts longer. There is a sort of a persistence of this light in the polar region, and this was a sort of a curiosity for us. We didn't know exactly why, and at the same time, and Dimitri Titov, who is right here, would probably be also extremely happy to describe this work. Cool. The Venus Express managed to map with the luxury of details the altitude of the cloud top, especially in the polar region, where we measured with the spacecraft a significant depression of that cloud layer. It's about northwards of 60 degrees of latitude, is about where we are here on Earth, actually. The cloud cover, which is approximately at 70 kilometers, goes down by about 2 scale heights, about 8 kilometers in the polar region. And there was a clear match between these limits and the increase of the light. So we did a modeling of that effect. We tried to understand whether those two phenomena were somehow correlated. And this entire campaign has been designed to map precisely this optical effect, especially do that in several colors. So we have a better idea of all of hazes and cloud absorption at altitude.
So you're basically, from our vantage point, you are looking at the refracted light coming around Venus, and you're able to deduce the cloud base, and you're able to deduce the temperature of the upper atmosphere?
We are able to deduce a few parameters which are connected. So this is a modeling issue afterwards. Analyzing our data, we will try to put these numbers together, but the idea is to probe what we call the scale height of the atmosphere. We are probing how fast density decreases with altitude. The faster it decreases, the shortest this phenomenon occurs. If it lasts long, which is the case in the polar region, it means that we have a larger scale height, which means the density decreases less rapidly with altitude than in the equatorial or mid-latitude regions. And this is also something that we want to model more through that phenomenon.
Okay.
Of course, it's a ground-based experiment, so we have much less detailed view compared to what's visible from Venus Express craft. But it's a global view. The idea is to have this measurement pole to pole, and that's why we have an interest to collaborate with the Venus Express project, which expressed a high interest in this coordinated campaign. And actually, one of the instruments of Venus Express is about to make a solar occultation from the orbits of Venus to probe the temperature in the same altitude region we are trying to map from the ground. So that's an extraordinary adventure to have this ground campaign associated with the measurements of the European spacecraft around Venus.
So with Venus Express, how does Venus Express sample? How does it measure the temperature of the atmosphere? Obviously, it doesn't do it in the same way that we would, but how does Venus Express do that?
I would really be happy to let my colleague Dimitri Titov reply.
Wonderful.
To this.
Well, thank you for your time.
Thanks. Okay.
I don't know what's your time there, so probably good afternoon already.
Oh, hi there. How are you doing?
Hi. Hi.
Yeah.
Okay, thank you. Thank you. Good afternoon, good morning. I don't know what's your time there, so because we are lost a little bit here.
The time here, it must be.
It's 5. It's almost 6 o'clock.
It's almost 6 o'clock in the evening for us, but the sun's still
Oh,
glaring.
good.
So yeah, we're still wide awake. We got a whole night ahead of us.
All right. So, well, about Venus Express, and well, first of all, I introduce myself. I was the mission science coordinator, and now Colin Wilson, he took over. But in the, say, 10 years ago, almost 10 years ago, I, together with Fred Taylor and Emmanuel Lelouch, we were thinking about Venus Express. I actually brought it to the European Space Agency. So what's the nice program that we're doing now about the temperature sounding? Well, first of all, we are very successful, Venus Express is very successful in sounding temperatures with radio occultations. We have now about 450 occultation profiles, well, spread all around the globe, from South Pole to North Pole, covering all latitudes, all longitudes, and local solar times. It's very nice and very precise sounding of the neutral atmosphere. So we're getting the temperature profiles from the mesopause approximately, say 100 kilometers, down to the cloud base. And this is, none of the infrared techniques is capable of doing this. Well, in addition to this, we are doing the mapping of the temperatures using the thermal emission spectroscopy by VIRTIS. And so it's also very good technique. It gives you distribution of temperature, mainly in the southern hemisphere. Very nice results, and we are collecting them, trying to plug into the different kind of models. First of all, dynamical models, chemical models, and I think that it works now. I mean, in general, Venus Express now is moving from the phase of collecting data to the phase of understanding the data using different kind of modeling.
So for Venus Express, what is the next big mystery that you hope to probe, or at least hope to measure before mission completion? Because you've got another couple of years, haven't you, until the mission's over?
Yes, right. So now we are already 6 years in flight, 6 years in orbit, and we have 2-3 more years. It's not clear yet, but because we do not know precisely what the amount of fuel is left on board, and this is the limiting factor. This is the main resource which limits the life. But we have two more years, definitely, and so we are going to continue our observations because what we're doing now, what Venus Express does, basically is that as long as possible baseline temporal coverage, because we see lots of processes, first of all, in dynamics of the clouds, in processes which really requires good statistics. So that's what we try to get as much as possible.
Okay, so what's the next big mystery that you want to you really want to resolve with Venus's atmosphere in particular? Because I understand that the mesosphere is still a big mystery, even though we've got a spacecraft in orbit.
Well, in the mesosphere, yes, we have a lots of measurements, but still there are lots of things which we do not understand. There are some kind of interesting turns and interesting wiggles in the temperature profiles. Well, some experiments, they clearly see some temperature maxima around mesopause. Well, and we are trying now to understand if those maxima are artifacts or some kind of results on incomplete modeling, or probably this is reality. Then we are going to make, in a couple of years, we are going to make air braking with the spacecraft. It's not yet decided, but there are plans, and the people at the Flight Control Center, they are looking into this. And what is interesting here, that we will basically sound the atmosphere of or high upper atmosphere of the spacecraft. So these are two things which probably are very interesting. Also, going from upper atmosphere, we are completing the coverage of the surface mapping in the infrared windows. And it's also, well, basically we are studying the, looking for volcanism. We have not yet found any volcano, I mean, lake flows. We will see some yeah, would be fascinating, but we have not yet found them.
Okay, that's great. Yeah, thank you. And I was fascinated with the volcanic research because I understand that it's a fascinating field. But thank you very much for your time. Really enjoyed speaking to you.
Thank you very much for that.
And enjoy
Yes,
the
thank
enjoy the Norwegian hospitality up there. I think you deserve a drink, especially this time of night.
Thank you. Thank you. Good luck to you.
Okay, so we're currently chatting to the Venus Express science team up in Svalbard, and Svalbard, of course, is up in the Arctic Circle, just north of Norway. And now we got Colin. Colin Wilson's back with us on the Venus Express team. So what have you got planned for the rest of the night? I'm sure your bed must be approaching.
Well, I mean, we're planning to go to bed when it gets. We are planning to go to bed when it gets dark again, which should be in a few months. It's 3 months or so. So, but there's a a lot of partying to be done. A lot of science to be discussed, is what I meant to say. So.
Absolutely. Well, the last time I was in Svalbard, in fact, that spot we had a barbecue on the shorefront. So I think you should probably do the same.
Yeah. Well, we're on the shorefront, and all we need to do is catch something to eat. So. We'll start looking. So we'll be here for a bit longer. I don't know if you want to come back to us later or if you want to go and do something else now. But Excellent. We're here if you want us later. Yeah, cool. Yeah, if you're around, we'll probably phone back in and see the wonderful snow and freezing weather. It looks pretty dark. Maybe it's best to cut back. Maybe it's best to cut back to somewhere warm. Otherwise, we'll all get cold.
Yeah, we're off to get a suntan. So.
Thanks.
You have a good night. And thank you very much, Colin, for chatting with us tonight.
Okay, talk later. Bye.
You take care. Bye-bye. Okay, so that was Colin Wilson, Venus Express science team up in Svalbard. And, of course, they're viewing the Venus transit as well from even that far north in Europe. But, of course, one of the best things about living on top of the world, or, at least viewing the Venus transit on top of the world, is that you often get 24-hour daylight. So they're currently viewing it even though it's gone 2 o'clock in the morning. So for now, I think we're going to leave them to it because I think they've probably got a couple of beers to drink or perhaps even bed. But for now, this is us up at Mount Wilson with the Astronomers Without Borders, and we'll come back to you shortly after our break. I think we'll get a coffee.
Okay, dissolve the three. Dissolve the three and go. Good, nice and easy. Come on up. Keep coming up. Up, 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 up. Now can you go up and go to the left now? Go to the left.